Okay, guys, we're going to keep talking about systems of equations today, and we're going to have a new method for solving it. Remember last time we said you could graph them, but the methods we looked at were using substitution and elimination. So today we're going to look at a method called Cramer's rule. Cramer's rule makes use of determinants of matrices. A matrix is just a rectangular array, right? Like here's an example of a matrix, and we put them in brackets, and there are just numerals in there. Now, if your matrix is a square matrix, it can be defined by a single numerical number called its determinant. Okay, here's the determinant. We use, it looks like absolute value notation, but if we're talking about a matrix, then we know, oh, this is saying find the determinant of matrix A. And matrices we label with capital letters. Okay, so the determinant, if we have a 2 by 2 matrix, to find the determinant, you multiply these two numbers, and then you subtract the product of these two numbers. So you do this number times this number minus this number times this number. Okay, and each matrix has its own determinant that defines it. Okay, so a note, I think we've already said all this. Matrices are enclosed with square brackets, while determinants are denoted with vertical bars. A matrix is an array of numbers, but its determinant is a single numerical value. Okay, so if we're going to evaluate the determinant of this 2 by 2 matrix, it's really easy. We simply say -3 times 8 minus 4 times 6. It's this times this minus this times this. So -24 minus 24, or -48, is the single numerical value associated with this matrix. Notice the matrix is in brackets, right? Matrix is in brackets. Determinant vertical bars. Okay, the determinant of a 3 by 3 matrix, not as easily defined. Here's the definition of it. You can look at that if you want, but it's way easier for me to just explain to you how to find that determinant of a 3 by 3 matrix. Same thing here. You can pause this and read if you want to know about minors and cofactors. It'll just be way easier for me to just explain how to find the determinant. And in order to do that, one thing that we do need is we want this sign array for a 3 by 3 matrix. So notice the signs alternate, starting with positive. Plus, minus, plus, minus, plus, minus, plus, minus, plus. So real easy to keep up with. All right, let's just go on and evaluate the determinant of a 3 by 3 and see how we're going to do that. Okay, so if I'm finding the determinant of this, all of that previous jargon meant I can evaluate the determinant down any row or any column that I want. The horizontal ones are rows, vertical ones are columns, right? And if I have a 0, I'm definitely going to pick the row or column that contains a 0, because that's going to cut my work by 1/3. If it has 2 zeros, it's going to cut it by 2/3. And as a matter of fact, if any row or any column is all zeros, your determinant is 0. Okay, so that we're in this course right here, solving these equations, we're probably not going to see that, but that's a good thing to keep in mind. So I'm gonna, because this has a 0, I can either choose to evaluate the determinant going across this row or down this column. Because these numbers are smaller, I'm gonna go across this row. Okay, so let's see what that means. I'll mark it just to keep us in mind. And I want to think about that that sign array, okay? Plus, minus, plus, minus, plus, minus, plus, minus, plus. Okay, now notice I didn't do these up here. I could have done these up here, and maybe this time I will, just to show, but it gets confusing if I have too much stuff going on. But here's what I want to know: plus, minus, plus, minus, plus, minus, plus, minus, plus. I'm going to go across this row, meaning I'm going to take this value here, right, and use this sign. So I've got a plus -1, so -1, okay, and then I'm going to mark out the row and the column that this -1 is a member of. And notice then that's going to leave a 2 by 2 matrix. And so I'm just going to evaluate the determinant of that 2 by 2. Now this is why I say if you put your plus and minuses everywhere, it may get confusing, right? So I usually just do it on the row or the column that I'm interested in. And as a matter of fact, so because I've got to keep in mind this is -3 and this is -3, right? So I may just go back and get rid of those that I now know I don't need. Okay, so -3 times -3. So 9 minus, this time says minus, -2 times -4, 8. Okay? And then I just work myself across to the next one. Oh, but this is going to be, it doesn't matter if it's -0 or 0, so this is going to be -0 times, I don't even care. What I would be doing is now finding this determinant of this 2 by 2, but it really doesn't matter since it's multiplied by 0. Notice how then that takes out that whole step there. Okay, and then go to the next one, which is here. So I'm going to have +2, +2. When I mark out the row and the column that the 2 is a member of, it leaves this 2 by 2 matrix. So I can say -8 minus, right, -8 minus +3. And then just evaluate those numbers. So it's -1 times 9 minus 8 is 1, plus 0, or -0, whatever you want to think, 2, -8 minus 3, -11. So I wind up with -1 minus 22. Okay, so the numerical value, the determinant associated with this matrix is -23. Okay, so don't worry, we're going to get a lot of practice at doing these determinants. Okay, but first, let's see, why are we doing these determinants? That's because Cramer's rule is a method by which we can solve systems of equations. Okay, and once again, if you want to pause it and read this, but it's just way easier for me to explain. So let's go on. Here's a caution. Cramer's rule does not apply if the determinant of your matrix D equals 0. Okay, if the determinant of matrix D equals 0, and really they should have vertical bars around that saying the determinant of D equals 0, then the system is inconsistent or has infinitely many solutions. So I know that, right? If we're going to get a solution, Cramer's rule will work. But if it's inconsistent, in other words, no solution or infinite solutions, it doesn't tell us that. So always evaluate D first, and then we'll have to switch to another method to tell us if it's which of these two choices it is. Okay, so it says let's use Cramer's rule to solve this system. So when we use Cramer's rule first, because we only have 2 variables here, I'm going to have 3 matrices. Okay, so this matrix, your D matrix that you want to evaluate first, consists of just putting up the coefficients of your variable terms. Now remember, it said let's always evaluate the determinant of D first, because we might not have to go any further. So 5 times 8 is 40, minus 7 times 6 is 42. So 40 minus 42 is negative 2. Okay, if it's not 0, then it means we can use Cramer's rule to solve this. So my next step then, I'm going to make a D sub x matrix where I replace the x coefficients with the solutions. So negative 1, 1, and then the y's stay the same, 7, 8. Then I'm going to make a determinant D sub y where I replace the y values with the solution. X is going to stay the same. So 5, 6, negative 1, 1. Okay, now I'm going to find the determinant of each one of those. So the determinant of D sub x will be negative 8 minus, negative 8 minus 7, negative 15. And the determinant of D sub y is 5 times 1, minus, okay, negative 6. 5 minus negative 6. So next time from now on, we're just going to save us some work, because when we get to these 3 by 3s, it's going to be a little bit lengthy. So hopefully we can just get to the point where we say, oh, 5 minus 6, we'll write 5 plus 6. But this is 5 plus 6, so 11. Okay, now Cramer's rule says that if we can find values for these determinants, then the x solution to this is found by D sub x over D. Right? My determinants of those. Okay, so that means negative 15 over negative 2, or 15 halves should be my x value. And y would be by finding D sub y over D, which would be 11 over negative 2. All right. So one time here, let's just check this. So you can always go back in and check. And if you get suspicious, not that you can't have a fraction, but you know, if you get something really crazy, these aren't too bad. You might think, is the book really going to give me a number like that? And it'd be easy. Just plug it in, at least one. Just plug it in one and see if it checks out. It should be the solution to both of these equations. I'll just plug these into the first equation. So we have 5 times 15 over 2 plus 7 times negative 11 over 2. And I want to know, does that equal negative 1? All right, so let's see. So what does that give us? 75 over 2 minus, all right, 77 over 2, which is negative 2 over 2, which is negative 1. Yes. And so it should also, if I just want to be doubly sure, it also needs to satisfy that equation, but it should. Okay, so just to clarify, that's Cramer's rule. Okay, you find the determinant for each matrix. You have a plain D determinant where you make the entries in your matrix the coefficients. In D sub x, you replace the x coefficients with the solution. In D sub y, you replace the y coefficients with the solution. Okay, and then you find the determinant of each one, and your solutions will be the x determinant over D, the y determinant over D. All right. Let's try that again. Yeah, let's try it with a 3 by 3 because we need practice at those matrices, at those determinants in particular. All right. So first off, again, just to save room, I'm going to go ahead. No, never mind. All right. So make this matrix that's going to use just the coefficients of all of my variables. So 1, 2, 1, 1, negative 1, negative 2, negative 1, 1, 3. And remember, if this is 0, then we don't even need to finish the problem this way. We need to choose another method. It'll mean there's infinite solutions or no solution. So first, before I go any farther and do a bunch of extra work, let's just see what the determinant for D is. Okay, and we can go across any row or down any column. Looks like this is just as good a row as any to go across. Okay, so I'm going to go across here. Plus, minus, plus. Okay, meaning to start with, I'm going to have positive 1 times the determinant from the 2 by 2 matrix that is left when I block out the row and column that this value is in. So negative 3 minus negative 2 plus 2, right? Okay. Then I'm just going to keep going across that row. Now I'm going to have negative 1, right? That's what those signs are there for. And then I'm going to cross out the row and the column that this 1 is in, and it leaves this determinant, so, or I'm sorry, this 2 by 2 matrix. So 2 times 3 is 6 minus 1 times 1. 6 minus 1. Okay. And now I'm going to use this one, so plus minus 1. We have minus 1, blocking out the row and column that this is in. Gives me negative 4 minus negative 1, so plus 1. Okay, so negative 3 plus 2 is negative 1. Negative 1 times 1 is negative 1. Okay, 6 minus 1 is 5 times negative 1 is negative 5. Negative 3 times negative 1, positive 3. So negative 6 plus 3, negative 3. Now I'm going to erase this just for the sake of room right here. So if you want to pause it while you study that. Okay. So we know that this determinant is negative 3. Okay. So now we're going to make D sub x matrix where I'm going to replace the x values with the solution. Oh, look right here. Be very, very careful with this. We need our equations to be in our general form where it's x plus y minus z equals negative 2. Not equal 0. We need those constants on the other side or you're going to mess up with your signs, right? So again, just for sake of room, I'm going to just say, okay, we know that's negative 2. Let's do this, see if this will help. So negative 2. I don't know what's better. A lot of these I don't really have sufficient room on, right? So negative 2. Can we keep that up? And then this, if we subtract 5 from both sides, we'd have negative 5. This, if we add 4 to both sides, we'd have positive 4. Okay. So x will be negative 2, negative 5, positive 4, the x column. Negative 2, negative 5, positive 4. And then y's will still be 1, negative 1, negative 2. Z's will be negative 1, 1, 3. All right, I'm going to go ahead and make all my matrices since I know now that I'm going to use Cramer's rule just to completely solve this. So for my D sub y matrix, I'm going to replace the solution column with the y's. So x's will be 1, 2, 1. Y's will be negative 2, negative 5, 4. And z's negative 1, 1, 3. And then same thing for D sub z, except, and again, put that line through your z's. You will not know the difference between a 2 and a z before too long. On the z's, you replace your z column with the solution column. So x's will remain 1, 2, 1. Y's 1, negative 1, negative 2. And z's negative 2, negative 5, 4. Okay, so I would, if I were you, I'd go back and check, okay, yeah, I replaced the x's, the y's, and the z's. They should all be the same thing. Sometimes we just get going and forget to do that. So now, let's find the determinant of D sub x. Okay, and this time I'm going to go down this column. Oh, if there were only a 0, what help that would be. But I'm going to try to choose, these are about the same, this one and this one. I'm just going to go down the column just to show us that we can pick anyone. It doesn't matter, right? Whichever one seems easiest. So that means, don't forget that, okay, so plus, minus, plus, minus, plus, minus, plus, minus, plus. Yes, they'll all alternate. Once you decide what your starting one is, wherever you're going, up or down, they'll alternate. Okay, so I'm going to start with negative 1 and cross out the row and the column that 1 is a member of, and it gives this determinant. So I have negative 5 times 3, so negative 15 minus 1 times 4, 4. Okay. Okay, now I'm going down this way using this column, so I have a positive negative 1, so that's going to be negative 1. When I mark out that row and column, I can see what matrix is left, so I have negative 15. And when I do this on paper, right, I'm doing this for emphasis for us. Yeah, I don't literally mark them out because, as you see, that have them all marked out before too long. So I've just got to keep in mind, sometimes I might put my finger across here and here while I do it, right? Put my finger across there because I don't want this marked out and this marked out, and then I can't tell what I'm doing. So I'm just doing this for us for emphasis to show us what's going on, but you may not want to literally mark them out unless you want to rewrite it 3 separate times. Okay, so I've got my negative 1 and I've got negative 15 minus 1 times 4. Okay, now I've got negative negative 2, so that's going to be positive 2. And then when I discard that row and column, it tells me that I need to do negative 2 times 1, negative 2 minus, and negative 1 times negative 5 is 5, so minus 5. Okay, So here's my d sub x, okay, which is -1 times -19 minus 1 times -19, interesting, plus 2 times -7. So I've got 19 plus 19 minus 14. So 19 minus 14 is 5, right? So 19 plus 5 is 24. All right, so I'm about to erase all this. Pause it if you need to continue taking a look at it. And I'll just put that determinant is 24. Okay, 24. Then we're just going to do the same thing for d sub y and d sub z. Okay, so on d sub y, I guess I'll go down this column. So don't forget, plus, minus, plus, right? Okay. And so I'll start with 1 times, let's mark that out, -15 minus 4, -15 minus 4. Okay, now I've got minus 2 times, whoops. Mark out the row and the column that the 2 is in, right? So -6. -6 minus -4, so plus 4. Okay. Now we've got plus 1 times, mark out the row and the column the 1 is in, -2 minus, -2 minus 5. So we have 1 times -19 minus 2 times -2 plus 1 times -7, or -19 plus 4 minus 7. So let's see, let's set -15 minus 7. Okay, let me do this again. -19. Let me double check real quick. Okay, so 1, -2, 1. Okay. All right. So -19 plus 4 minus 7, -19 plus 4 is -15, minus 7 is -22. All right, so I'm going to erase that again. If you need to pause it, to check it, do so, or to study it, whatever. -22. Okay, and let's do d sub z's determinant. Okay. again, I guess we'll just go down. Doesn't matter, this row or that row is pretty good. Just go across the first one again. Okay, plus, minus, plus. So I have a positive 1. If I discard the row and column that that 1 belongs to, I have negative 4. Negative 4 minus 10. Okay, now I have minus 1. Discard the row and column that that 1 is a member of, and we have 8. Minus, 4 times 2 is 8, minus negative 5, so plus 5. Okay, now I have a positive negative 2, so it's going to stay negative 2. And then when I discard that row and column, we'll have negative 4. Negative 4 minus negative 1, so plus 1. Okay, so we have 1 times negative 14 minus 1 times 13 minus 2 times negative 3. Let's see what we have here. So negative 14 minus 13 plus 6. Okay, so negative 27 plus 6, negative 21. All right, I'm going to erase it again. All right, negative 21. Okay, so now Cramer's rule tells us that if we can find these determinants, we can solve this system. X will be the d sub x value over the d determinant, so 24 divided by negative 3, negative 8. Y will be the d sub y value, so negative 22 over negative 3. And z will be the d sub z value over that, so negative 21 over negative 3 or positive 7. Okay, so our solution, remember, is a ordered pair, x, y, z, negative 8, 22 thirds, and 7. Okay, if we wanted to check these values, plug them in, ideally into all equations, right? I'm not going to take the time to do that. Hopefully we didn't have a mistake on this one, but you'll have fractional answers. And I tried to quickly double check my math in my head. I didn't see any error. But if I was doing this on a test or something, I'd plug it in there and check to make sure. Okay. Let's try it again. One more time, okay? All right, we're using Cramer's rule. So first of all, I need to just find the determinant D. So 2, 3, 1, negative 1, 2, 4, and 4, negative 1, 2. Luckily, this time, it's in the right format for us. Now, before I go any further, I'm going to find that determinant of D. Okay, so maybe we can shortcut this a little bit. Let's go. Oh, it really doesn't matter on any of these, does it? Let's go across here because when I do a plus minus plus, it'll make them all positive. So plus, minus, plus. So I'll have a positive 2. Let me do this. Okay, so we'll have a positive 2. And then I'm going to mark out the row and the column that the 2 is a member of. So then we'll have 4 minus negative 4. 4 plus 4. Okay. Then we'll have a negative, negative 1. So plus 1. Marking out that row and column, we'll have 6 minus negative 1, so 6 plus 1. Okay, and then we'll have plus 4 times 12 minus 2. 12 minus 2. All right, so that gives us 8 times 2 is 16. Going to start shortening some of this, right? 7 times 1 is 7, and 10 times 4 is 40. So what do we have here? 23, so 63. Okay, I'm going to erase. All right, 63, which means we can use Cramer's rule. So now I'll just go back and make the rest of my determinants, my matrices. D sub x, I'm going to replace the x column with the solution, negative 2, negative 3, 17. Y's will remain negative 1, 2, 4. Z's will be 4, negative 1, 2. Okay, now let's find d sub y. X's will remain 2, 3, 1. But I'll replace the y's with the solutions, negative 2, negative 3, 17. And the z's will be 4, negative 1, 2. And then d sub z. The x's will remain 2, 3, 1. Y's will remain negative 1, 2, 4. And z's will be the solution column, negative 2, negative 3, 17. Kind of double check them and make sure that I've got my solution column and my x's, then my y's, then my z's. Right? All my x's look like this. All my y's look like this. All my z's look like this. Right? Quick double check. It's just save us some issues, hopefully. All right, so if I'm going to find the determinant for d sub x, okay, oh, this one and this one's about the same. Let's go down this one. Okay, so we got plus, minus, plus, minus. Right? Whenever you start, always start from here for a plus, and then you can go anywhere and they alternate, right? Okay, so that means I'm going to have a positive 1. And if I get rid of these values, we'll have negative 6, minus negative 17, or plus 17. Okay, then we'll have positive 2. And if I mark out these values. We'll have negative 6 minus negative 17, so plus 17. Interesting. Okay, and then I'm going to have negative 4. So marking out these gives me positive 2 minus negative 12, so plus 12. Okay, so 17 minus 6 is 11 times 1 is 11. Okay, 17 minus 6 is 11 times 2 is 22. And then 14 times negative 4 is negative 56. Let me double check my math. Yeah, negative 56. Okay, so then we have 33 minus 56. 33 minus 56. So negative 23. Again, see, I look up here to see, and so that'd be 23 over 63. And it makes me wonder if it's supposed to be like 21 over 63. So I'm going to recheck my math. All right. So 17 minus 6 is 11. 17 minus 6 is 22. 12 plus 2 is 14 times 4. That is 56. 33 minus 56. That is negative 23. All right, so short of going up and rechecking all my determinants. Okay, I'm going to erase. Okay, negative 23. At least that's what we have. Okay, so now let's do d sub y. All right, and maybe we'll go down this first column. Okay, so plus, minus, plus. So we're going to start with a 2 times negative 6 plus 17. Okay, then we have a negative 3. Negative 4 minus 4 times 17, 68. Okay, and then we have a positive 1. And 2 minus negative 12, so 2 plus 12. 17 minus 6 is 11 again, so there's that 22. Okay, so this is negative 72 times negative 3, so it's positive. 72 times 3, 206? 216. I'm going to check myself over here. 72 times 3. Yeah, 216. And then plus 14. All right, so here's 230, 252. Okay, I'm going to erase. All right, 252. Okay, and d sub z is, let's go down Oh, let's just go across this first row again because with my signs that'll be positive. So plus, minus, plus. I'm going to start with a 2. Okay, so 34 plus 12. And you can do that in one step. I'm just writing it out like that for emphasis, right? Okay. And then plus 1. 3 times 17, so 51 minus 3, 51 plus 3. Okay, minus 2. 12 minus 2. All right, so we have 34 plus 12, so 46 times 2, 92, plus 54, okay, minus 20. Okay, so 92 plus 32, 124. Let me double check my math. 126. 126. All right, I'm going to erase. $126. Okay, now that means our solutions are d sub x over d. So negative 23 over 63. Right? Y would be d sub y over 3. So 252 over 63. Just seeing what that is over at the side. That's 4. And z is 126 over 63, which is 2. So I'm wondering about that one. If I were you on these, I would check my answers. So you plug it in to one of these equations or go back and check that. Once again, doesn't mean you're not going to get a fraction, but that's a kind of a crazy fraction. I'm not going to take the time to go back and find my mistake. Hopefully, if there was a mistake, then you've already found it while you were working through this with me, and you're like, wow, why did you put 12 there when it was 14 or whatever? Okay. All right, so don't forget. Check on that. Okay. Now they're saying show that Cramer's rule does not apply. And really, you might have some on your homework that says that, but on the test they're not going to say that. You've just got to know what it means that Cramer's rule don't apply. So you would start out like normal, right? Make your determinant of D, so 2, 6, 1, negative 3, negative 9, 2, and 4, 12, negative 3. And we are going to find this determinant before we do anything else, because there may be no need to continue. All right, so this time I'm going to go across this row. So plus, minus, plus, minus, plus. So I'll have a 1, and then discarding that row and column, we'll have negative 36 and plus 36. Okay. And then we'll have minus 2 times 24 minus 24. And see where this is going. Whoops. And then minus 3. Times negative 18 minus negative 18, so plus 18, which means we have 1 times 0 minus 2 times 0 minus 3 times 0. So that determinant of D is 0. And remember, to get our solutions, we divide each determinant D sub x, D sub y by D. So if it's 0, we can't divide by 0, so you can't get a solution that way. It means there's either no solution or infinite solutions. It doesn't ask us which, but if I still needed to solve this equation, then I'd have to go back to my elimination and substitution method to get those actual solutions. Okay, that does it for this section. Let me know if you need anything. See you next time.